John has 100 meters of wire mesh to fence a rectangular enclosure. What is the biggest area he can enclose with a wire mesh? So let us represent that in a diagram. It is rectangular like that, and the total length is 100 meters. So it has a length, let's say it is L meters, and a width W meters. So the first thing we need to do is to represent the dimensions in the same unknown. So we can represent the width in terms of the length. So the width will be the same as the total length minus 2 of the lengths. So minus 2L, and because we're just considering one width, we divide that by 2, because when you take away 2 lengths, that and that, you're going to be left with 2 widths, that and that. So we divide that by 2. So you can simplify that. 2 is a common factor there, so you will have 50 minus L meters as the width. So from there you will try and get the area. So the area of that will be, the area of a rectangle is given by length times width, and we have the length as L times the width, which is 50 minus L. So that will be 50 L minus L squared. Okay, so that is in square meters. So from there we know that when the area is maximum or minimum, then dA dL should give us 0. So let us get dA dL of that area. So dA dL of that area will be 50 minus 2L. So that is our dA dL. So at maximum or minimum, this should be equal to 0. So when that is equal to 0, we can solve for L. So it means we have 2L is equal to 50. So that L is equal to 50 divided by 2, which is 25 meters. So when you have that, we can try and check if this length will give us the maximum area. So we can use the diagrams where we have the length and we have the A, the L, and then we have the diagrammatic representation of that. So let us see. So what we're going to do, we're just going to pick a point or a value to the left and a value to the right of the length that we have. So we have 25. So to the right we have 26, and to the left we have 24. So when L is 24, first of all, when L is 25, we expect dA dL to be 0. But when it is 24, let us just substitute that value in our dA dL. So when it is 24, we have 50 minus 2 times 24, that is 48. So we have 50 minus 48, which is 2. And to the right, when it is 26, we have 50 minus 52. So that will be negative 2. So when it is positive, indicate with a positive gradient, and when it is 0, it is just flat, and when it is a negative, it is a negative gradient. So it therefore means that the area is maximum when L is 25. So that maximum area is given when L is 25. So when L is 25, W, or the width, is 50 minus L. So you're going to have 25 times 50 minus 25 is still 25. So that will give us 625 square meters as our maximum area that John can enclose with that particular wire mesh.